Hello everyone, we're from Group 9 KPB. We're going to present our report about determining alcohol contents in foods and beverage. So this is all the section that we want to explain in this video.
Alcohol is an organic compound consisting of one or more hydroxyl groups bonded to a carbon atom of an alkyl group. Alcohol can also be thought as an organic derivative of water, in which one of the hydrogen atoms could be replaced by an alkyl group, usually represented by R in an organic structure. Based on the location of the hydroxyl functional groups on the carbon chain, alcohol can be divided into three types, including primary alcohol, secondary alcohol, and tertiary alcohol. Alcohol can be found in various foods and beverages like tapai and beer. Therefore, an experiment could be conducted with the purpose of determining alcohol content.
Gas chromatograph is a method that has a function to perform dynamic separation and identify types of volatile organic compounds. This method has a separation process based on the partition of the sample between the mobile phase and the stationary phase. Generally, chromatography is used for qualitative and quantitative analysis in a mixed solution. The stationary phase will act as a phase that interacts with other compounds that do not want to be analyzed, so that it takes longer to reach the detector, while the mobile phase will bring the compounds that we want to analyze faster to the detector. Next is the structure of the chromatography that supports the separation of compounds up to the detector. The first is the carrier gas, or can be referred to as a mobile phase, whereas the mobile phase must have a several conditions such as being inert, so that the compound that we want to identify does not interact with the mobile phase. The second is the flow controller. This action regulates the flow of the carrier gas according to the analytical method and the compound. The third is the front inlet. This is used to inject the sample through a port that provides heat. The fourth is the column oven. The role is to heat the sample in the form of a liquid until it becomes the vapor phase. The temperature in the oven column needs to be controlled so that the sample can survive in the vapor phase as long as it passes through the oven column to the detector. Then there is a column where the sample gas flows along with the mobile phase from the injector to the detector. The last is the detector, the plate to transmit signals to the computer so that a chromatogram graph can be seen, which shows the retention time of the detected compounds.
The principle of gas chromatography is that in the first stage, a sample that consists of various compounds will be injected into the front inlet. The liquid sample will then be evaporated into a gas, which will go to the column of the gas chromatography, where the separation process occurs with the help of a mobile phase. In general, the mobile phase used is an inert gas, where in this experiment helium gas is used. In the second stage, when the gaseous sample reaches the column, it will interact with the stationary phase so that a separation process occurs between the compounds that make up the sample based on their interaction with the stationary phase. Compounds that have higher interaction with the stationary phase will have a long retention time, while the ones with lower interaction with the stationary phase will have lower retention time. Thus, in the third stage, compounds that have different retention times will cause the compounds to be detected by the detector by different times, resulting in a chromatogram consisting of peaks with different characters. This indicates that there are differences in the compounds in the sample solution. The different peaks will have an area that can obtain a regression equation that can be used to determine the alcohol concentration in a sample.
Next is part 3, that is explanation about the method. In this practicum, there are two methods are used, namely external standard and internal standard. The standard external method is a method that uses an external solution as a standard to determine the concentration of an unknown compound in a sample, which is in this case is alcohol. While the internal standard method is based on the comparison of the relative response of the analyte to the response of one or more compounds so as to minimize errors that may occur. In this practicum, the internal standard solution is water and methanol, which has almost the same properties as alcohol, and the external standard is ethanol, which is assumed to be alcohol on the sample. The first thing that needs to be provided is an external solution consisting of ethanol, and for the internal solution are methanol and water. Then the ethanol solution will be added with the internal solution with a composition of 5:1 in a volume of 100 ml for each concentration. The volume of internal solution added to the ethanol solution should be recorded for adjustment when adding to the sample. The two solutions will be prepared at a concentration of 10, 20, and 30 ppm. Then in the second step, 1 microliter of each external solution and internal mixture and ethanol will be injected into the front inlet. Both solution will produce a chromatogram that shows the retention time of each component, where the external standard that comes out first is distilled water, followed by ethanol. While the internal standard, the first is distilled water, methanol, and the last is ethanol. In addition, section 4 also produces a regression equation or calibration curve that can be used for determining the concentration of the sample after the sample got injected. Then the sample will be added respectively with an internal and external solution, where the volume of addition of the internal solution to the sample must be the same as when used in the standard section. with the hope that the ethanol is the same as the alcohol sample so that it has the same retention time. Then the chromatogram results will come out in section 6, which shows the area of the compound assuming the same ethanol as the sample.
The following is the data obtained from the experiment on determining the alcohol content in foods and beverages. In this experiment, the foods and beverages used was a solid sample in the form of Tapai and a liquid sample in the form of beer. Therefore, the following environmental and observational data were obtained. By applying the internal standard method and the external standard method in this experiment, the data obtained for the external standard solution are, and the data for the internal standard solution are.
After obtaining all the data, we can calculate it to know the concentration of alcohol in both samples, and a more deep explanation will be given of the data processing that has been carried out as well as the things that can affect the result of this alcohol. In the external standard section, data will be obtained through the ethanol concentration range of 0.5, 1 and 3% volume of ethanol, with each area for the standard solution are 337.82, 1451.3 and 4478.8. So the external standard curve is formed with the regression equation is y equal to 1615.6x minus 334.15, with the equation r squared equal to 0.9947, where y is the area and x is the concentration. After finding the regression equation, the standard solution or ethanol will then be added to each sample, will be injected into the chromatogram so that the area of Tapai and beer is 54.87730 and 3733. The concentration of both samples is influenced by the dilution of each sample, where the Tapai is diluted 100 times and the beer is 2 times. With this information, the alcohol concentration in Tapai and beer can be calculated by substituting the area value for y in the regression equation, so that the alcohol concentration or x for Tapai is 24.079% and beer is 5.03498%. Then we also find out in section 4 that there is a theoretical ethanol content list on the packaging. There are 3% volume ethanol of Tapai sample and 5% volume ethanol of beer sample. In this way, the error and accuracy can be obtained for each sample. On Tapai has an accuracy of minus 602.63% and beer is 99.3004%.
Meanwhile, for the internal standard solution was obtained through the chromatogram from the injection of the standard internal solution into the gas chromatography. Therefore, we will obtain a chromatogram with the x-axis in the form of percentage V per V ethanol with the different concentration variations, which are linear, with the y-axis in the form of peak area. These data will then be plotted to obtain a standard curves of the standard internal solution with the x-axis in the form of concentration and the y-axis in the form of peak area, so that we would acquire a regression equation. Internal standard solution, which will also be injected to the instrument to obtain a chromatogram composed of the peaks of the Tapai and beer sample compounds in the internal standard solution. Then the ratio of the peak area will be substituted into the regression equation of the standard curves of the internal standard solution, which will obtain the alcohol concentration in Tapai and beer samples, which is 19.49% and 5.01%, with the accuracy value for the calculation results of each sample, namely minus 449.52% and 99.73%. However, the concentration calculation is influenced by multiplying the diluent factor, where the Tapai sample has been diluted 100 times while the beer sample has been diluted only 2 times.
Based on some literature, it is stated that the standard internal method has higher accuracy than the external standard method. This is due to the presence of an internal solution, namely methanol, which has similar properties to the sample, so that it can increase the precision and accuracy of the results by looking at the ratio between the internal and the sample, where during the sample preparation, it is very possible for the alcohol to evaporate, which can cause errors. This can be seen from the higher accuracy on the internal compared to the external.
This is the error that may happen in this practicum. There is impurities, diluent factor, instrument error, and sample injection.
In addition, from the chromatogram, it can be seen that the retention time is different for each compound, especially methanol and ethanol compounds contained in each sample. The following is the retention time data obtained from the chromatograms of the Tapai sample and beer sample for each methanol and ethanol compounds. From these data, it is known that methanol compounds will always come out first compared to ethanol compounds. That's because the interaction between the ethanol compounds and the stationary phase is higher than the interactions between methanol and stationary phase. In this experiment, the stationary phase used tends to be polar. Therefore, applying the principle of like dissolves like, polar compounds will prefer to interact with polar compounds, where from the table below shows that the relative polarity of ethanol is greater than of methanol. That is because by the amount of carbon chain in ethanol and methanol, where the higher the number of carbon constituents, the more polar the compound is.
The conclusion for this experiment is that the sample used is Tapai and Peer using the internal standard and external standard method with gas chromatography instrument, thus obtaining the concentration and accuracy value of Tapai and Peer in external standard and internal standard. These are some references that we use. And that's all from Group 9. Thank you for watching.